Hello, everyone. This is Mr. Suraj, and today, along with me, my colleague VK is here, and he is doing his PhD from IIT Roorkee, and he is a basic computer science guy. And let's discuss with him. Hello, hi VK. How are you?
Hello, sir. I am good. How are you?
Yeah, I'm also doing good. Going ahead, in order to guide to the students, what are the key subjects you suggest in the basic computer science?
I would suggest subjects like theory of computation, data structures, algorithms,
Mm-hmm.
and discrete maths and graph theory. So, these are some basic core computer science subjects that students should uh,
Mm-hmm.
take care of during their study.
Oh, okay, understood. And then, what are the key topics you suggest in the theory of computation?
So basically, starting from the beginning, students should
Mm-hmm.
be looking for learning about the concept of languages. Like there are different
Mm-hmm.
classes of languages, so they should start from the regular expressions, regular languages. Then they should
Uh-huh.
move to the context-free language. Apart from that, context-sensitive language, and at last they will study about the Turing machines. So these are
Okay.
some basic topics in theory of computation that we mainly get to study in our bachelor's.
Mm-hmm. Okay. And then, like going ahead with the algorithms, what you suggest? Why exactly we study these subjects? Algorithms.
These subjects basically tell us how machine works and how we can
Okay.
make the machine work more efficient. Because
Mm-hmm.
algorithm is something like we tell machine how to do a particular task. So there can
Okay.
be to do a task, there can be a lot of different ways. So we have
Mm-hmm.
to find the more efficient way to do a task. For that, we
Mm-hmm.
write different kind of algorithms. For
Mm-hmm.
example, we have to find a path between two node of a graph. So there can be
Okay.
different ways to find it. So we have
Mm-hmm.
different kind of algorithms. Like one person
Okay.
give a algorithm, then somebody optimize it and give another algorithm. So that's
Mm-hmm.
now to optimize our time and computation of the machine. We
Mm-hmm.
generally study different kind of algorithms, and this is
Mm-hmm.
the basic core concept of learning algorithms to make machine more efficient.
Oh, okay. Understood. And then, like, what are the key algorithms or key topics in this subject?
Key topics should be like when somebody starts algorithm, they will go through some basic searching and sorting algorithms like ingestion
Mm-hmm.
the merge sort, quick sort, heap sort, in which they learn how
Mm-hmm.
the array can be rearranged so that we will
Mm-hmm.
get it in a arranged manner. And the second
Mm-hmm.
one, after that, they will go to the algorithms for finding in the graphs like Prim's algorithm, Kruskal's algorithm, and
Mm-hmm.
Dijistra's shortest path algorithm. These algorithms basically tell us to reach one point to another point, which is the shortest path that we can take so that we can reach in the shortest period of time. So these are different
Okay.
algorithms that we study.
Okay, understood. And now going ahead with the data structure. So what exactly is the data structure, and then what are the key topics in that? Why exactly should should study?
So data structures mainly tell us what are the different ways we can store a data in our system.
Hmm.
Like in the form of array, we can put a data. So basic data structure that we start with when we start learning data structures is about
Mm-hmm.
concept of arrays. After
Hmm.
arrays, we move to the linked list. Linked list is also one of the method to put a data in a system. In
Mm-hmm.
another way is to put the data in a stack.
Mm-hmm.
Everything has its own pros and cons that we study in the chapter as a whole. After that, we have
Okay.
some calculations of push
Hmm.
and pop in stack variables, how we can do it. And
Mm-hmm.
apart from that, we have another data structures like trees are there, binary trees
Mm-hmm.
are there, sparsely tree, red black trees, different kind of trees are there. That is also one way to put a data in trees. So basic data structures are like that we study are arrays, linked list, queues are there,
Mm-hmm. Mm-hmm.
tags are there,
Okay.
trees are there. So these are
Okay.
the different, and these all are the methods of putting a data in a system. Like if we want
Okay.
to put our data in a system, which
Mm-hmm.
are the efficient according to our work. Every data structure is efficient. We just
Okay.
need to work with our condition to match up with the characteristics of that data.
Oh, Understood, understood. Okay, okay. So this is about the data structure. Now going ahead, you mentioned another subject which is a graph theory, right? So why this subject is important?
Basically, graph theory is very important because each and every problem can be decomposed in a form of a graph, and we can
Hmm.
study that problem by decomposing it in a form of a graph and applying all the properties that a graph takes. For example, I give
Hmm.
you, let's study the structure of a people in a very big system like a Facebook system. So we can
Okay.
consider like all the peoples are node, and there must be
Hmm.
an edge from a person who are friends with each other, right? So
Okay.
we will get, if I am a friend with you on Facebook, there will be an edge from me, my node to your node. If I am not a friend with you, there won't be any edge. So at last we will get a very huge hierarchy of a graph, right? So after that
Hmm.
we can start applying all the characteristics and properties of a graph on that data, like
Okay.
what is the degree, like how many people are connected with me. After calculating my degree, you can find how many
Hmm.
people I am in friends with, right? So for
Okay.
finding a
Okay.
friend, you just have to apply the degree of a node calculation on the graph.
Hmm.
So this is how
Hmm.
we can study the graph and all the problems in the real life also, like finding the Google Map uses the graph algorithms for finding the shortest
Okay.
distance to travel from one
Okay.
point to another. So graph theory is very realistic part of maths because it is almost used every day in all the sphere of life.
Okay. Okay. Understood. And then in terms of the subject, what are the key topics you suggest in the graph theory?
In the graph theory, you will start from learning the basics of graph, like what are the node
Hmm.
edges, what are the degrees, uh, how degrees are connected. There are some
Hmm.
handshaking lemma and everything is there. Then we move to
Hmm.
different kind of graphs, like what are star graphs, what are Hamiltonian
Hmm.
graphs, Euler graphs.
Okay.
So these are the topics in the graph. And apart from that,
Hmm.
there are some terminology, like there is a graph, there is a star graph. So what is the um, what do you call that, centroid of a graph, you find out diameter of a graph, you can find out to find the
Okay.
basic characteristics of the graph. So these are the
Hmm.
learning topics in the graph theory.
Okay, 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 understood. And now the another subject which you have mentioned is a district mathematics, right? So
Yes.
I want to understand what exactly is the difference between the normal mathematics and the district mathematics.
Okay, so I will start with the word discrete. So discrete
Mhm.
has a opposite called continuous. So now you understand the
Mhm.
meaning of discrete. Discrete
Mhm.
means which is not connected to each other, but as a part they are together.
Mhm.
It's not continuous, it's discrete. It means that whatever we are learning, we can apply
Mhm.
that method on that particular individual or entity, not as a whole
Okay.
continuously, right? So some
Oh,
chapters
yes.
in discrete maths, we get to study are some recurrence relations. Recurrence
Mhm.
relations is one of the very important chapter in discrete maths. We learn about
Mhm.
polynomials in recurrence
Okay.
relation. Characteristic equations are there. It's a it's
Mhm.
a like a bridge between algebra and algebra and um, number theory.
Good.
That is our
Number three.
recurrence relation. And apart from that,
Okay.
there are some generalization theory, general how to write
Mhm.
Fibonacci number in recurrence relation, because
Mhm.
you can represent Fibonacci number in the form of a recurrence relation, and you can work on that in the from the algebra point of view, right?
Oh,
And
okay.
graph
Okay.
theory is also the part of discrete maths. Okay,
Okay.
graph
Okay.
theory also comes under discrete because we are studying the node as a whole, right? One
Mhm.
node we study, another node, so it's like a discrete mathematics. Some part of
Okay.
probability like random variables, that is also the
Okay.
part of discrete maths.
This is maths.
So
Okay.
these are different topics in discrete maths that we study. Mathematical inductions is there because
Uh-huh.
when we start learning mathematics, we get to know how to prove a theorem or how to prove some uh, conjecture. So we can use a
Mm-hmm.
mathematical induction method, which is a part
Okay.
of discrete maths.
Okay. 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 Understood. And now, how exactly this discrete mathematics is useful for all these computer science subjects like algorithms, theory of computation, data structure, graph theory, and other subjects?
Okay, so the point is, 50 years ago, there were nothing called computer science, right?
Okay.
Everything was maths. You can look into old computer scientists, they all were mathematicians. So they start
Okay.
working on a problem, and when
Okay.
they find a problem, they try to
Mm-hmm.
decompose into the problem that they know very well. That's a mathematics, right? So
Mm-hmm.
they start decomposing in the form of either graph, either recurrence relation, either mathematical induction, and then they start
Okay.
learning and studying the problem to get into a solution. So for working on
Uh-huh.
any project or any problem, either from computer
Okay.
science or any different sphere of study, mathematics
Mm-hmm.
is needed. And for that,
Okay.
discrete maths, and discrete maths is very old form of math. It started with Euler in 16th century, 17th century,
Mm.
when he first
Okay.
formulated a problem of graph theory, right?
Okay.
So computer science is just like evolving field past 80, 70 years, right? Before that,
Uh-huh.
everything was maths. So to
Okay.
understand
Okay.
computer science, we have to understand discrete maths and how things
Mm-hmm.
are working uh, in a
Mm-hmm.
particular algorithm. So if you open any book on discrete maths, the best one is the
Mm-hmm.
Rosen book. You can see every exercise has some programming exercises. So whatever you are
Okay.
learning, you have to implement in computer science also. So this is
Okay.
where
Okay.
there is a bridge between maths and computer science, that is discrete
Computer science.
maths.
Discrete mathematics.
Yes.
Okay. Understood. Understood. Okay. Now, VK, I wanted to ask you another question. You mentioned that your research is going into this basic computer science, core
Yes.
computer science subject.
Yes.
So, what kind of exact that research is about, and that if you can tell?
Okay. So if you are asking about my research area and what I am doing right now,
Mm-hmm.
my research is basically based on complex analysis. That is like I study about different graphs and networks,
Mm-hmm.
and it's like networks not in a way like we are working on computer networks. It's not that. What we
Okay.
do, we decompose a problem in the form of a very big graph with millions of nodes, and I
Mm-hmm.
basically work on a concept. It is known as influence block maximization. Basically, it happens.
Okay.
I will give you a basic overview of my research, how it works.
Uh-huh.
Just imagine you are having data of some people on Twitter. That is some 100 million people are there, and you need to
Uh-huh.
sell a product, right?
Okay.
So what you do, you cannot just simply go to people and ask them just buy my product. It's not that way. So
Correct. Correct.
what people do right now, they give some set of product to some set of people, and what they do,
Mm-hmm.
they advertise it, they try to make it viral, and they
Correct.
and the information propagates through the whole graph, right?
Correct.
So the
Correct.
problem here is, the problem statement is, what are the seed initial node that you choose from the graph that will maximize the spread of your information? Okay.
Oh.
Like
Okay.
imagine I am connected with, out of 100 million, I am connected with 1 million people. Like I'm a very big celebrity on Twitter, I have 1 million
Mm-hmm.
followers. So the
Okay.
product will be given to that person, and he just need to tweet
Mm-hmm.
it about that product. This
Oh.
product is being launched, and even though I am
Mm-hmm.
not connected to that person, it will start coming to my feed. That is based on
Mm-hmm.
the neighboring nodes. Like if one node will
Oh.
get the information, it will get propagated to another node, and the propagation, what I need to do, the two problem statements, the two problem is there. First, we need to identify the initial node that we have to
Okay.
work on, so that the problem will reach to the product will reach to more number of people. And the second one is
Mm-hmm.
how many outreach we are getting, like how many node we can influence, right?
Okay.
So
Yes. Yes.
this is the virality problem, and
Mm.
this can be also applied in the field of epidemiology, like in epidemic, like in COVID also, you can see
Uh-huh.
the problem spreads, the diseases spread from one person to another, and we can
Correct.
map the whole community, like the people of India, in the form of a graph, and how they are connected,
Mm-hmm.
and we can study the
Okay.
problem. So basically, the fair influence maximization takes care ki whatever the
Mm-hmm.
seed node that we are choosing initially, it will gives us
Mm-hmm.
the maximum output, right?
Okay.
So
Okay. Understood.
my research is basically on the
Mm-hmm.
graph information diffusion.
Okay, very good. Thank you, VK, for explaining your research. So, at the end of this discussion, I just wanted to ask you one question. What exactly you suggest to the upcoming students? What should they study upon, and then what should they focus upon in the computer science core area?
Yeah, currently, if the student are doing their bachelor's, the field of LLM right now, large language models, is very much evolving. You can see the
Mhm.
AI and machine learning. We have been hearing these terms from past 15 years, but right
Mhm.
now the game has completely changed after this LLM thing. Like Chat GPT is there, then there are different other GPTs that coming in the market. So they are
Correct.
constantly doing the research. The people in DeepMind, they are doing all those researches there, and they are giving us the product. So this is today we
Mhm.
can say that we are in a race of AI. Like
Correct.
we are training the model, the sharpness of the
Mhm.
model comes from the data that we are feeding them, and it is increasing
Correct.
day by day. Right now Nvidia has also jumped into this AI model training.
Correct.
So
Correct.
these
Correct.
companies are doing very brilliant work. They are publishing high resources research paper in different big
Mhm.
conferences. So these things were
Okay.
not there in 2015 or 16. People were just
Okay.
doing linear regression, supervised learning, unsupervised learning
Mm.
in machine learning. but right
Uh-huh.
now but right now the things has completely changed. Now you have to go into deep learning, you have to go
Okay.
into graph neural networks, you have to train
Mhm.
NLP, the models. So this, and
Mhm.
right now you have also seen two Nobel Prize has been given in the field of computer science in
Correct.
physics and
Correct. Correct.
chemistry. So basically
Correct.
the AlphaFold, the chemistry Nobel Prize, the AlphaFold for which they got the Nobel Prize, what
Uh-huh.
they did the protein structure. They used AI to predict the protein
Mhm.
structure. Because if you give me
Oh,
two
oh.
minutes, I can give you a basic idea if you have time for that.
Yeah, yeah, yeah. Sure, sure. Go ahead. We have the
Yeah.
time. Yeah.
So the basic idea is for
Mhm.
which they got the Nobel Prize in chemistry. They made a software
Uh-huh.
called AlphaFold that is available for
Okay.
everyone to access. So what they do
Mhm.
basically is, see, in the
Mhm.
nature there are 200 million different kind of species,
Okay.
and every species has their own structure in their body, right? So they have
Correct.
different, our body is made up of different configuration of proteins. Okay, so how the
Correct.
proteins are in our body,
Mhm.
that gives us the shape and size and nature of mammals or birds or everything, right?
Mhm.
So out of
Mhm.
200 million different kind of protein structures, till now our researchers are able to only figure out only 200K, like 2 lakhs different, only 2 lakh different protein structures. Okay,
Correct.
the thing
Correct.
is, identifying a protein is a very resource heavy, computation heavy, and expenses heavy process, because we go
Okay.
for the crystallography. We have different kind of
Mm.
crystallization method to find a protein. But the thing is,
Correct.
in USA in 1996,
Uh-huh.
they started a competition where a people will come with a model and they tell, I can give you the
Uh.
prediction of a protein, like this protein can exist. and
Oh, oh, oh.
and this competition is held every year in USA, right?
Oh,
So the thing
yes.
is, people are not getting the efficiency. Like they are 100%, no, they are 60% efficient, 70% efficient, which boils down to almost nothing. Because even though one string is
Mm.
unmatched, the everything, the genetics and everything will change, right? So
Correct. Correct.
the thing is, this is very important to study the protein structure, because it will give us how cancer cell works. This is one of the
Mhm.
bigger question. Like, because the
Mhm.
shark fish has the ability to never get a cancer, right? It will never get
Okay.
cancer. So people just biologists or physicists just try to study their bodily in configuration, what they are made up of, so they
Mhm.
are not able to get the cancer in their cell, right? So this is a very
Mhm.
big research. So this company called Google DeepMind, they came up with
Uh-huh.
the idea of
Mhm.
making a model. What they did, they took all the 200K different protein structures in their system, and they
Mhm.
trained their
Oh,
machine on the basis of that. And after that,
okay.
whatever the new protein comes, the machine will
Mhm.
predict its shape, its size, its configuration based on the information it has already of all the different discoverable protein, and they are able to achieve 96 to 97% of accuracy right now.
Oh,
So it's a very
oh, oh.
big leap in the human mankind study of different protein structures, and that's why they have
Mhm.
given the Nobel Prize for them, because it will
Uh-huh.
accelerate their study and their research, right? Now people
Exactly, exactly.
will be more interested in doing AlphaFold things, how proteins are
Mm-hmm.
working. So these are the different domains that you should jump upon right now if you are a computer science
Okay.
student, so that you will
Uh-huh.
get an edge. Because right now we are in the starting budding phase in AI. After 10 years, 20 years, things will change. We will start making movies with the help of AI. We will start
Correct.
even proving theorems in mathematics that has been unproven till now for hundreds of years with the help of AI.
Uh-huh.
People are working on that.
Uh-huh. Okay,
So these
okay.
are the
Understood.
different
Understood.
implications of the field of AI that I will suggest student to study. At least for LLM,
Okay.
they should read some basic papers. They should
Mm-hmm.
watch some videos, connect to some people who are really working on these domains. So I
Okay.
will suggest this to students.
Okay, okay. Understood, VK. But then my another question to you is then how exactly these core computer science subjects are related to these LLM models and the deep
Okay,
learning and AI?
okay. Okay, so I will give the answer for that. For example, take the example of this theory of computation, right? So in
Mm,
that we study about languages, we study about different NFA, PDA, DPTA. So these are the different models that we study that computer works in themselves. For example, you
mm,
write a code, the code is then broken into syntax, and that syntax into tokens in computers, right? And that
yeah.
token is given to the computer to understand what is really happening. That token will be former
Mm,
decomposed into machine language, that
mm,
decompose into binary 0 1 0 1, machine will
mm,
understand.
mm, mm,
So think about it,
mm,
how these all things are working. These all things are working with the help of regular expression. Okay, that is the
mm,
part
mm,
that we study in theory of computation. So for
mm.
understanding the deep and bigger and higher level concept, you have to have the background in maths, in computer science.
Okay.
So these are the topics that you should be looking forward to jump into it,
Mm,
because you won't get that feeling of getting something knowledge out of those things if you are not very much
mm.
sound in your basics. Okay, so
Okay,
after
okay.
completing all these things, you will have this confidence to read the papers. In the paper also, there are lots of maths are there. Probability will be there, summation, integration, everything will be there. So without knowing all these things, I will not. I don't think anybody will get high into it, because if you look into the researchers'
Understood.
background also, everybody has
Correct.
done their maths, their PhD. Everybody is
Mm-hmm.
having a PhD in their domain. So after that they are able to work to that magnitude, right?
Yes,
So
yes, yes.
everything starts from the smaller steps. Whatever the topics we have
Mm-hmm.
discussed right now, the topics,
Mm-hmm.
these are very important to understand.
Mm-hmm.
The because if you don't know how to write an algorithm, if you don't know to check whether an algorithm is right or wrong, so basically
Uh-huh.
it will make no sense for you to work, right?
Exactly, exactly. That is
Yeah.
true. That is true. Yes, yes. Thank you very much, VK, for your time and the knowledge which you have shared. And
Thank you, sir.
have
I
a
hope
yeah,
I have contributed something significant what you trying
yeah,
to.
yeah. Definitely, definitely, definitely. Yes, yes. Okay. Have a nice
Thank
day.
you, sir.
See
Thank
you.
you, sir.
Bye. Yeah. Bye.
Okay, bye, sir. Thank
Bye.
you.
Bye. Bye.